Hey guys, quick video about recognizing when you can factor and when you maybe should factor when verifying trig identities. So two types of factoring we're mostly going to do GCF and difference of squares. There is some like sum and difference type factoring, but for the most part it's going to be these two. So number 5 from the book assignment. Looking at this one, cotangent squared times cosecant squared minus cotangent squared equals cotangent to the fourth. I noticed that both terms have cotangent squared with them. So anytime you have like the terms here, stuff matches with both of them, that's a good indicator that you could use GCF factoring. Now, what can be helpful with this for GCF factoring, what I found works in the past has worked for some students, is instead of thinking of it as cotangent, cosecant, cotangent, think of it as x squared, y squared minus x squared. So all I did is I said cotangent is x, I changed cosecant to y, and now I'm looking at this top equation. Well, looking at that, more students would recognize, oh, I've got an x squared with both terms. I can factor out an x squared, and that's going to end up being x squared times y squared minus 1, like that. And it's really the same principle with this. The only difference is now instead of x's and y's, it's cotangents and cosecants. So if I factor out a cotangent squared, it's going to be not cosine, cotangent squared times cosecant squared minus 1. And then from there, take a look at the key to help you out if you're still having trouble, but try that and see what you can do with it. Now this one's a little bit tougher. It's a difference of squares. Some of you are probably going to recognize this, but not everybody. And it has to do with the fact that it's not really squared, right? It's to the fourth. But anytime those two terms have an even power, 2, 4, 6, 8, other even numbers as well, and they're separated by a minus, that is a difference of squares. So this would factor to cosine squared minus sine squared and cosine squared plus sine squared. Now, if you FOILed this back out, you could verify that this is true. The first, cosine times cosine, that's cosine to the fourth. Cosine times sine minus sine times cosine, those are going to cancel each other out in the middle, and then on the ends you're going to have minus sine squared times sine squared is minus sine to the fourth, so this works out. Now, get it to this point, take a look at your Pythagorean identities and see which one of these you can start to reduce. Notice that one side of the original equation, cosine squared minus sine squared, and I've got a cosine squared minus sine squared over here. Let's look at our Pythagorean identities and see what we could change this to.